Hi, Physics 1. Mr. Janowski here. This is Chapter 5, Homework 2, Problem 5, and this is going to be the first 2D kinematics problem that we do. So this is going to be a bit of a doozy. If you've never seen something like this before, it's going to be a lot. So just pay attention, get what you get out of this, and we'll see how it goes. So what's going on here? I hit a golf ball across level ground, so this is just flat. There's no hills anywhere. The ball leaves the club with an initial velocity of v initial is 35 meters per second at an angle of 65 degrees above the horizontal. And we want to figure out two things. So let's start off with step 1, like we always do. So step 1, for part A, how long will the ball be in the air? Okay, well, how long in this context means time. So time is question mark seconds. Part B, how far away will the ball land? Well, I'm hitting this golf ball. It's going to land some distance sideways away from me. So what I'm really looking for is delta x. So delta x is equal to question mark meters. So those are the two things we want to figure out here. So the next thing we're going to do, and this is a bit of a departure from before, is what is called step 0. So this is new. Step 0 is find the components. Sorry, it takes me longer to write than it does to speak. Find the components. I can't stress this enough. Step 0 is find the components. It is not draw a triangle. You will often have to draw a triangle, but that is not what step 0 is. It is not draw a triangle. It is find the components. Let me underline the word components here. So what does that mean? Well, let's see what's going on. I hit this golf ball with an initial velocity 35 meters per second at an angle of 65 degrees above the horizontal. So let's start with that idea. So I'm hitting this thing 65 degrees above the horizontal. Notice 65 is steeper than 45. So when I drew this, I made clear that this is steeper than 45. Like 45 would be somewhere out like this. I didn't do that because 65 is steeper. So what that means is V initial is 35.0 meters per second, and it's at this angle here of theta is 65.0 degrees. So that's the angle I'm hitting this golf ball at. So we need to figure out the two components of this thing. We want to figure out how quickly is this thing going sideways. So we're going to call this V sub x initial. So this is our initial sideways. We need to be clear that that's an x. And we will call this one V sub y initial. How quickly is this ball moving vertically initially at the moment that I hit this golf ball? All right, so next thing to do is we've got to label our sides. I'll use the yellow one. I never use the yellow one. So this is a right triangle. Okay, so here is my right angle in here, which means V initial is definitely my hypotenuse. This is the longest side. And then I need to figure out which of the other sides is A and which of the other sides is O. So it doesn't matter which one you start with. We'll start with V sub x initial. So is this side adjacent or opposite to the angle we're working with? Well, here's the angle we're working with, and Vx initial is touching this one. It's next to it, which means this side is A. And therefore, this side over here, well, this is opposite the angle. This side is, all the way across the triangle. It's opposite from the angle. So this side over here is O. I'll write it right here. So that side is O. So now I have to do some trig to figure out both Vx initial and Vy initial. Doesn't matter which one you do next, but I'll do it alphabetically. And we'll start with Vx initial. So I'll write it over here so we have lots and lots of room. So I want A, I know theta, and I know h. So which trig function does A, h, and theta? Remember your trig functions. So, ka, and toa. Okay. It's ka. That one has A and H. So the next thing you should write is the definition of, let me give myself a little bit more room for what's coming later. The definition of cosine. So cosine of theta is A over H. So what does that really mean here? Well, that means that cosine of 65.0 degrees, I'll just write theta for now, is equal to a over h. Well, what is a? A is Vx initial. And what is h? A is V initial. All right, so if I do this and I solve for Vx initial, then I will have the component I'm looking for. So multiply both sides by V initial. That would give us V initial times cosine of theta is equal to Vx initial. Okay, well, V initial is 35.0 meters per second times cosine of 65.0 degrees. And this is Vx initial. And if you ask the calculator, let me make clear that that's an x. Oh, now it looks even more like a y. Vx initial. I'm trying to write too little here. That's a Vx initial. Yeah, ask calculator. What is 35 times the cosine of 65.0? Making sure, of course, that we are in radians mode. I'm sorry, that we're in degree mode. I'm lying to you. Vx initial ends up being 14.7916. Okay, I'm going to call it 14.8. So 14.8 meters per second is this one. So I've got that. Now I need to get Vy initial. Now, if you wanted to, you could use the Pythagorean theorem at this point because you know two of the sides. You know h and a, and you want the other one. So you could use a squared plus b squared equals c squared. You wouldn't be wrong to do so. But I think it's easier to just keep doing trig. Do trig again. See how that works. So yeah, Vy initial is O. Well, I know A and I know H, but I know H a little bit better. A has got some rounding in it, so I'm going to stick with H. So which trig function does O, H, and theta? That would be sine. Look at SOHCAHTOA. It's going to be so. So start in the same place. Boop. Sine of theta is equal to O over H. And what that really means, I'll try to go a little bit faster here, is sine of theta is O is Vy initial over H is V initial, which means V initial times sine of theta is equal to Vy initial. So what that means is 35.0 meters per second times sine of 65.0 degrees is Vy initial. So ask your calculator, 35 times sine 65.0, and you get 31.720, et cetera, et cetera. We'll round off a little bit. Vy initial is now equal to 31.7 meters per second. So this side here is 31.7 meters per second. All right, now let's do a quick mini step. See if this makes sense. If I look at my triangle, H, well, it's the hypotenuse. That has to be the large side. Which side is medium and which side is small? O is medium, A is small. Okay, so we've got that. Does that match my numbers? Yeah, 35 is my largest number, 31.7 is my medium number, and 14.8 is my smallest number. So that gives me a good check that I've done my tree correctly. I picked the right thing, put it in the right order. So I'm happy about that. That's a good thing to have. So we've got all that. This is why it's so important to draw your triangles correctly. So we've got all that. And now finally, we are ready for step one. And I'll tell you what, I'm going to actually go to the next board to do step one. So I can't copy all this stuff, but I can copy this. This is going to take a lot of room on the Jamboards. So finally, we're up to step one. Unfortunately, we're going to have to keep flipping back and forth for this. So step one, all year long, is make a sketch. So what's happening in this sketch? I'm going to hit a golf ball across level ground. It's going to leave my club with an initial velocity of that. I want to know how long it's in the air, how far away it lands. Okay, so here is level ground. Here's me with a golf club. There's my golf club. I've hit the ball. The ball launches in the air at a fairly steep angle. So there's the speed lines behind the ball. The ball's going to do one of these. It's going to fly in a parabola, and it's going to land some distance away over here. And the end of the problem, the ball is like that, right above the ground. So we've got that. Good. There's step one. I could put in more information, but that's enough for this. On to step two. This is going to be a doozy. I'll try to squeeze it all in down here. So step two is your variable bank. Now, last chapter we did one-dimensional problems, and there were 6 variables. This is a two-dimensional problem. There are 12 variables. There's actually 11 because we're using time twice, but that's how it's going to be. So anyhow, yeah, here's what's going on. X initial. That's an equal sign. X final. Vx initial. Use all of the subscripts you need to keep this stuff clear. Vx final. A sub x. And t. So we've got that. Actually, you know what? To be consistent, this is annoying. But I think this is the best way to teach it. Even though x comes first in the alphabet, I'm going to do it the other way. I'm going to start with y's. Y initial. Y final. Vy initial. Vy final. A sub y. And t. So those are 6 of my variables. My other 6 variables are going to be, they're going to look kind of similar. X initial. X final. Vx initial. Vx final. A sub x. And t. All right. So that's what we've got. Now we've got to fill in all of these things. Oh, there are so many things. So y initial. Y initial is the height we start at. Just like last chapter, always make y initial 0. So 0 meters. Y final is the height that we end at. Well, look at what's going on here. If this is y initial, what height does it end at? It ends at the same height. So this is also 0. Okay, so that's something. Vy initial. How fast is this golf ball moving vertically at the beginning? That's why we did step 0. So let's go back to this screen. Vy initial is 31.7 meters per second. That was the whole point of doing step 0, is to get that number. So that is 31.7 meters per second. That's how quickly the ball is moving vertically at the beginning. Vy final. How quickly is the ball moving vertically at the end? You could write a question mark and still do the problem. That would work. But you're better off realizing that this is one of those special cases where the ball is at the same height at the end as it is at the beginning. Remember, the down motion mirrors the up motion. So if at the beginning the ball was going vertically at 31.7 meters per second, at the end it will be going 31.7 meters per second down. So we're going to write minus 31.7 meters per second. Again, you could do this problem if you just wrote question mark there, but this will make it a little bit better. A sub y, what is causing this ball to accelerate in the y direction? It's gravity. So it's minus 9.8 meters per second squared. And finally, we get to t. So what is t? How long does it take for the ball to start here, go all the way up, come back down? We don't know. This is actually what we're looking for. So question mark seconds, which actually means on the other side, this is the same t. So I'll write that one in there now. So we've got that. Okay, now on to the x side. X initial. Where are we sideways at the beginning of this problem? So x initial. Just like usual, start with 0. Call that one 0. X final. Where are we sideways at the end of this problem? So that's over here. Well, it's definitely not 0. The ball has moved sideways. It's moved some distance. We don't know what this is. This is what we're trying to figure out in part B. So question mark meters. Vx initial. How fast is the ball moving sideways initially? Go back to your step 0. Vx initial was 14.8 meters per second. So that's why we have that one. Nope. Writing's a little bit weird. Okay. 14.8 meters per second. Skip Vx final just for a second, and let's look at A sub x. All right. So when we hit this golf ball, it flies through the air. We know that gravity is accelerating the golf ball downwards. What is accelerating the golf ball sideways after it leaves our club? The answer is nothing. Nothing is going to make this golf ball accelerate left or right. Gravity accelerates it down. Nothing accelerates it left or right. So that means a sub x is going to be 0 meters per second squared. That's an important part, and that's going to be very common in these kinematics problems. In the 2D kinematics problems, gravity will accelerate the thing up and down. Nothing will accelerate it sideways. So we've got that. So Vx final, think about that. If it starts at 14.8 meters per second sideways and it doesn't accelerate sideways, then its sideways velocity doesn't change. So its sideways velocity will always be 14.8 meters per second. So that's a key part of doing these problems. Keep that in mind. It took a little while because there's so many variables, but we filled them all out. Now on to step 3, which step 3 is what things are you looking for? All right, well, in part A, we're looking for time. Whoop. For part B, we're looking for x final. I should do that. 3B, 3A, 3B, we're looking for x final. So I've got to choose a kinematics equation. Let me bring the kinematics equations over from the previous slide. All right, hopefully there'll be enough room for it there. All right, so I've got to choose an equation to get me t. So which side do I want to use? Do I want to use the y side or the x side? Just trust me on this. Always start on the y side. So here we are with step 4 for part A. So for step 4 for part A, we're trying to figure out what time is. So I need to pick an equation that has time. Okay, so it could be 1, 2, not 3, could be 4. And I need to know all the other things. Okay, well, in this case, I have all of the other things. There are no other question marks, which means I can use the easiest one, which is equation number 2. You won't always be able to do that, but in this case, you can. So V final is equal to V initial plus AT. All right. Are there any useful zeros? There are not in this case. I don't have any useful zeros. I mean, y initial and y final are 0, but they're not in this equation. So there are no useful zeros. So I've got to just do the math. So 5a over here. The name of the game is to get t by itself. So first I'm going to subtract v initial from both sides. So v final minus v initial is equal to at. Then I'm going to divide both sides by a. That would give me that. Now I'm going to switch left and right. All right, the a's would cancel over here. And I would end up with something like this. T is equal to v final minus v initial over a. And to get the order of operations right, you might need to use parentheses up here in your calculator. So we do that. Time is equal to v final on the y side. Oh, I should have been using those. So many things. Sorry. I should be more specific about what I'm doing here. We're working with the y side. So we've got 4 v's in this equation. We've got 2 a's in this equation, so you should be using the subscripts. Anyhow, t is equal to vy final. So minus 31.7 meters per second minus v initial final. I'm sorry, vy initial minus vy initial. So that is minus positive 31.7. All of this divided by a sub y, which is g, which is minus 9.8 meters per second squared. Okay. Minus 31.7. Subtracting 31.7. All right, convince yourself that that does not equal 0. It's a negative number minus a positive number. It's not going to equal 0. So I now have minus 63.4 on the top. I'm going to divide that by minus 9.8. And that will give me time equals 6.4 46938. All right, let's round this up to 6.47. And its units will be seconds. So put a box around it. Now let's do step step just to make sure that our answer makes sense. We solved for the right thing. In part A, we wanted the time in seconds. That's what we got, time in seconds. So this is about 6.5 seconds. Does it make sense that if I hit a golf ball, it might hang in the air for 6.5 seconds? I don't know if many of you are golfers, but that's definitely possible. That's a reasonable amount of time for a golf ball to be in the air. So we're happy about that. So we give it a check. So there's that. On to part B. So yeah, at this point we're halfway done. But don't worry, because we've done almost all of the things. We've already done our step our step 0, our step 1, our step 2, our step 3 for B. So now we just have to go all the way to step 4B. We need to pick an equation. So which equation do you want to pick? Trust me on this one. Don't even think about it. The equation you want to pick at this point will be equation 1. Any other equation is only going to get you into trouble. So delta x is equal to v initial t plus 1/2 a t squared. And I did it again. Delta x is equal to vx initial t plus 1/2 a sub x t squared. Okay. So the pro tip of the day, are there any useful zeros? Look carefully. There actually is one. A sub x is 0. That never happened in the last one. So if a sub x is 0, that means 1/2 times 0 times t squared. That whole thing is 0. Which means this equation, which looked a little bit messy originally, just got a lot simpler. Delta x is equal to vx initial times t. So on to the math, which I will do in green. Hopefully this makes it a little bit easier to see. All right, step 5 for B. I've just got to put in the numbers. So delta x is equal to vx initial. So that's this number, 14.8 meters per second, times t. What is t? Well, I didn't know t before, but that's why we did part A. We got t is 6.47 seconds. So ask your calculator, what is 14.8 times 6.47? And the calculator tells you 95.7 something. There's actually a bit of a rounding thing going on here. All right, 95.8 meters. Put a box around it. Do step Does this make sense? Did we solve for the right thing and give it the right units? Yes, we wanted delta x in units of meters. We got that. 95.8 meters. Well, that's about 100 meters. Can you hit a golf ball about 100 meters? Yeah, pretty easily. This is one of the shorter clubs you would have in your bag to hit a golf ball about 100 meters. For me, this is like a sand wedge. This is like nothing to hit a golf ball this far. So it's a very reasonable distance. So you give it a check. So yeah, that's it for this. My guess is the first couple times you see this, you might be very confused. There's so much going on here. Let's go back to the beginning. Yeah, there's a lot of things going on here. Try to think of this problem in the framework of the problems we did last chapter. We're adding a couple of new things, and there's more things going on. But if you remember how we did the problems in chapter 4, this won't seem so wildly different. So start with step All right, the new thing is step 0. You've got to find the components of your velocity. So that took some time. That's why we did the trig. We have the components. So if this thing is going 35.0 meters per second at this angle of 65 degrees, what we want to know is how fast is it going sideways and how fast is it going up. So Vx initial plus Vy initial gives us this V initial. So we started with this ugly vector here, broke it into 2 pretty components here. So that was the whole point of step 0, was to get these numbers. That one there, this one here. After we did that, then it kind of got a little bit more normal. make your step one, make your sketch of what's going on. So I'm hitting the golf ball. It's going to fly through the air, come back to the ground. This is where my problem begins. This is where my problem ends. Now you do step two. You've got to figure out the variables. In a 1D problem, there are 6 variables. In a 2D problem, there are 12 variables, but really 11 because time is the same on both sides. So you do that. This will take some thinking and some experience to get this right, but eventually you'll be able to do it. Fill out all the variables, and then do step 4. Do the y side first when you're doing these problems. Always do the y side first. Do step 4, pick an equation, solve for your thing. We got a time. Do step, yes, this makes sense. And then you go back and you do step 4 on the x side. And then you do, you do step 5 on the x side. And there you go. So yeah, this is quite a lot. I went kind of deliberately. This took a long time, but eventually you'll get good at this stuff. So hopefully you found that helpful.